Good morning, 9th standard. The next exercise we are going to do is exercise 13.3. It is based on the surface area of a cone. Before we start doing the questions, let's write down a note. A right circular cone has three parameters. First one is the radius of its base. The second is its perpendicular height, or also called as the vertical height. The height and the radius are perpendicular, and then we have the slant height. So for a right circular cone, we have vertical height represented by h, slant height represented by L. Be careful, do not confuse L with length. L is the slant height. And the third thing that we have is the radius of base, because the base is a circle. So the radius of the base is represented by R. And these three form a right angled triangle. So the relation between them exists as given by the Pythagoras theorem, L square equals to h square plus R square. So sometimes in questions you might be given any of these two. There are three parameters. You might be given any two, but you may need the third one. In that case, you find the third missing parameter using this relationship, and then you can apply the concerned or the related formula to solve your question. Let's quickly write down the formula that we have. Since exercise 13.3 is based on surface area, so we are writing down the formula only for the surface area of cone. So the curved surface area of cone, by cone we are referring to a right circular cone. So the curved surface area of a cone, which is, the curved surface is a sector. If you have watched the video I shared with you, you would know that the curved surface of a cone is a sector. Roughly writing down, this is a cone and this actually has two surfaces. This is the curved surface. If this is the cone, this is the curved surface, which is a sector, and the base circle. So this is what a cone comprises of. For the curved surface, we need the area of the sector, and since this is not in the syllabus, we are not going into the derivation. I shared the video, you probably remember. The curved surface area of a cone is given by pi r L, and the total surface area of cone will be given by the curved surface area plus the base area. So the curved surface area is pi r L. The area of the base, the circle, is pi r square. Taking common factors separate, so you get pi r L plus R as the formula for the total surface area. Now let us do the questions from the exercise. Now we are going to learn how to apply the formula for the curved surface area of a cone and total surface area of a cone to solve real life problems. Question number 1. Diameter of base of cone is 10.5 centimeters and its slant height is 10 centimeters. Find its curved surface area. Let us write down what's given to us. From exercise 13.3, question number 1, we've been given the diameter of base as 10.5 centimeters. Slant height. So slant height is represented by L. This is given as 10 centimeters. We have to find out the curved surface area of the cone. The curved surface area is given by pi r L. Now we don't have R, So let's find out R. R will be equal to 10.5 by 2. So you can simplify and then use it here. Removing the point, there will be a 10 in the denominator. So I'll be using it as such. I'll simplify during the application of the formula. Again, in this exercise, you've been given that pi is 22 by 7 unless otherwise stated. So pi is 22 by 7 into radius is 105 over 20 into the slant height is 10. So 0 and 0 get cancelled, 2 gets cancelled with 22, and this gets cancelled with this. So I get 11 into 15 equals to 165 centimeters square as the answer for the curved surface area. Let's do the next question. Let's look at question number 2. Find the total surface area of cone if the slant height is 21 meters and the diameter of base is 24 meters. Let's write down the answer. Question number 2, we have been given slant height as 21 meters and diameter of base as 24 meters. So if slant height is 21, that means L is 21 meters, and from here if diameter is 24 meters, we can find out the radius. This will be 24 by 2, which is 12 meters. Now we need to find out the total surface area. The formula is pi r L plus r, using the values 22 by 7 into the radius is 12 into, in the brackets, 21 plus 12, simplifying. Now you can just leave the answer in fractions. There is no need to convert these into decimal numbers. It will be completely fine. So this comes out to be 8712 by 7 meter square. And if you divide and give the answer approximately, you can skip that part. You will be given marks still here as well. Now let us do question number 3. Third question. Now you have been given the curved surface area. The curved surface area of cone is 308 centimeters square. Slant height is given. You have to find out the radius of base and total surface area of cone. So we will be making an equation using things given and find radius, then apply the formula for total surface area. Let's write the answer. Question number 3. We have been given the curved surface area of cone is equal to 308 centimeters square. Along with this, we have been given the slant height. Slant height is L, represented by L. The value is 14 centimeters. So these are the things given to us. We have to find out the radius and the total surface area. So let's write the formula for the curved surface area of cone. It is pi r L. Its value is 308. Let's use the value of L here. 22 by 7 is the value of pi. R we don't have. L is 14 equals to 308. Simplifying. So we have 44 into r equals to 308. Let's solve for r. 308 divided by 44. This comes out to be 7 centimeters. So radius of base is 7 centimeters. The next thing, we have to find out the total surface area of cone, and the formula is pi r into L plus r. Using the values, radius we calculated 7, using the values of L and r in the bracket. So 22 multiplied by 21. Let us see what the answer is. The answer comes out to be 462 centimeter square. Now we have to do question number 4. If you have observed, the first 3 questions were direct applications of the formulae. Now, when you have learned how to use the formulae to solve the questions or how to apply the formulae, we are now going to deal with some real life problems. Question number 4. A conical tent is 10 meters high and the radius of its base is 24 meters. Find first the slant height of the tent. Using the height and the radius, you have to find out the slant height. Now the relation between these three is given by the Pythagoras theorem. L square equals to h square plus r square. Using that, we will solve the first part. Second part, the cost of canvas required to make the tent if the cost of 1 meter square of canvas is 70 rupees. To find out the cost of canvas, first of all we will find out the area of canvas needed to make the tent. And the area of the canvas required to make the tent will be given by the curved surface area. Now you will ask why we are not calculating the total surface area, because when a tent is used, the tent is used on the lateral surface and the top surface. The tent is not spread on the base. Since in a cone we don't have a top surface, the top has a vertex, there is no surface on the top. If we are going to find out the canvas needed to make the tent, you will only need to find out the curved surface area. Once you have the area of the canvas needed to make the tent, you can find out the cost for the same. Let's write the answer. Question number 4th, you have been given the height. So every time they refer height, you mean the vertical height. So h for a cone, height of the cone is 10 meters. It's a conical tent. The radius of the base represented by r, this is 24 meters. The first part is to find out the slant height. Slant height means you have to find out the value of L. So we know the relation between h, r and L. It is given by L square equals to h square plus r square. If you don't remember this, try to remember how a cone looks like and you will be able to remember. This is the right angle triangle formed. This is h, the vertical height. This is the slant height, and this is the radius of the base. So using this, you can always write the Pythagoras relation. Use the values and find out the value of L. So L square comes out to be 676. Taking square root of 676, L comes out to be 26 meters. Second part, we have to now find out the cost of canvas. And before we find the cost of canvas, we will first find out the area of canvas needed to make the tent. So for this, step 1 will be area of canvas needed to make the tent, and this will be given by the curved surface. It is very important that you know whenever a tent is used, it is not used on the base. The base is excluded. Keep this in mind. It's very important. Now for a cone, the curved surface area is given by pi RL. Using the values of R and L, R is given 24. L we obtained in the first part, it is 26. Again, you have some values there which do not have any common factor. So you can obtain the answer in the form of a fraction and leave it as such. The units are meters. So the area will be in meter square. Once you have the area, we can find out the cost. So step number 2 is to find out the cost. We have been given cost of 1 meter square canvas. This is 70 rupees. So cost of 13,728 by 7 meter square canvas. 70 multiplied by the fractional value we obtained. So this comes out to be 1,37,280 rupees. This is the answer for the 4th question. Now the next question we are going to do is question number 5. Question number 5 is, What length of tarpaulin 3 meters wide will be required to make a conical tent of height 8 meters and base radius 6 meters? So we have done a similar question where we are required to find the length of tarpaulin needed to make some object. In this case, we have been asked to find out the length of tarpaulin needed to make a conical tent. First thing we will do is we will find out area of tarpaulin needed to make the tent, and using the area and the width of tarpaulin, we will find out the length required. Assuming that extra length of material will be required for stitching margins and wastage in cutting is approximately 20 centimeters. Now this is something you need to keep in mind. Whatever length we calculate from the first part, along with that length we need some extra length of the material which will be needed for the margins and the wastage that will occur during the cutting. And for this question, pi is 3.14. Once again, you have to find out the length of the material needed. But when we find out the material needed to make a tent, the material will be calculated in terms of area. Since we have to find out the length and not the area, what we will do, we will use the area that we calculated and the width given in the question, the width of the material given in the question. So area and the width can be used to calculate the length of the material. And once we have the length, we can give the answer. Now let us write the answer for this. Question number 5. So they are talking about a conical tent. I'm just quickly going to write down the dimensions given to me for the same. For the conical tent, the height is 8 meters and the base radius is 6 meters. I need to find out how much material will be needed to make the conical tent. Now if you can recall from the previous question, in case of a tent we only need the lateral surface area and the top area. We do not include the base area. In case of a cone, there is no top surface, so we only have to find out the curved surface. So step 1 will be to find out the area of material required, and the material here is a tarpaulin cloth. If you want, you can write for yourself the area of material required to make the tent. This will be given by the curved surface area, which is equal to pi r L. But I don't have L. I only have height and radius. So I'm going to find out L first using the Pythagoras theorem. L square equals to h square plus r square. L square using the values of h and r. L square comes out to be 100. So L comes out to be 10 meters. Now let us use this value in the formula. Pi is 3.14, radius is 6 and the slant height is 10. So this comes out to be 31.4 into 6. I have adjusted the decimal with 10. I'm just leaving it as such. The area will be in meter square. Now step 2. In step 2, I will find out the length of the material required. I have been given the width of material or the tarpaulin as 3 meters. This is given. Therefore, length of the material will be given by area over width. So the area from the first part, 31.4 into 6 over the width is 3 meters. Solving, these get cancelled. 31.4 into 2, this comes out to be 62.8 meters. Since its length, the units will be meters. Be very careful, the units of length. Now Step number 3, before we give the final answer, we were told that there is some extra length needed for stitching margins and the wastage that will occur during cutting. So we have to include that length into consideration. So extra length required. So this is because of the wastage and the cutting. So this is given to me as 20 centimeters. This extra length will be added to the length that I have calculated. Adding the two answers, the length that I calculated and the extra length that is required. Adding these two, I'll give my final answer. But the units are different, so I'll need to change. Converting these into meters, this comes out to be 0.2 meters. So therefore, total length of material required will be given by adding these two, 62.8 plus 0.2, and the answer comes out to be 63 meters. So you can give the answer as 63 meters. That completes question number 5, and it's a very important question. The next question is 6th question. The slant height and base diameter of a conical tomb are 25 meters and 14 meters respectively. You've been given the slant height and the diameter of the base. Find the cost of whitewashing the curved surface at the rate given. The rate is 210 rupees per 100 meters square. So before we find out the cost of whitewashing the curved surface, before the cost, we need to find out the area to be whitewashed. The area to be whitewashed is the curved surface of the tomb. Let's find out the curved surface area and then find out the cost of whitewashing. Question number 6th. Let's write down what's given. I have been given the slant height. Slant height is 25 meters and the diameter of base. The base diameter is 14 meters. So this means L is 25 and D is 14. So from here I can find out the radius. R will be equal to 7 meters, half the diameter. Now, first step is to find out the area to be whitewashed. And since the whitewashing is to be done on the curved surface, we will find out the curved surface. It's indicated in your question. Formula to find out the curved surface area of a cone is pi RL. Pi is not indicated, so we will use it as 22 by 7 using the values of R and L. These get cancelled. I've got 22 into 25. This comes out to be 550 meters square. So this is the area to be painted. Now for this area, let us find out the cost. Step 2, we will find out the cost here. Now cost of whitewashing. Now this is given as, for 100 meters square, it is 210 rupees. Now for 100 meters square is given, we need to find for 550. So we will be applying unitary method. For 100 meters square, from here we will find out for 1 meter square. This will be 210 divided by 100. And now we can find out for 550 meters square. So this will be the cost for 1 meter square multiplied with the area to be whitewashed, and multiplying these two you can obtain your answer, and the answer comes out to be 1155 rupees. This is the cost of whitewashing the curved surface of the conical tomb.